High-level design, HLD, encompasses various topics that provide an architectural overview of a system or project. Here's a list of topics typically covered under high-level design. 1. System architecture overview: the overall structure of the system, including the main components, their interactions, and how they fit together. Key elements. Architectural patterns, e.g., client-server, microservices, layered architecture, main components and their responsibilities, technology stack and platforms. 2. Component design: detailed design of individual components within the system, including their roles and interactions. Key elements. Component interfaces and APIs: interaction diagrams, e.g., sequence diagrams, data flow between components. 3. Data flow diagrams, DFD, diagrams representing the flow of data within the system. Key elements. Data sources and destinations: processes that transform data storage and retrieval. 4. Database design of the database, including schemas, tables, and relationships between data entities. Key elements. Entity relationship diagrams, ERD, normalization and data integrity rules, data access patterns and indexing. 5. Interface design of user interfaces and external system interfaces. Key elements. User interface, UI, design mockups or wireframes, API design for system interactions, integration points with external systems. 6. Security architecture design considerations for securing the system, including access control, encryption, and threat modeling. Key elements. Authentication and authorization mechanisms, data encryption methods, security protocols and compliance. 7. Scalability and performance considerations designed to ensure the system can scale and perform efficiently under varying loads. Key elements. Load balancing and failover strategies, caching mechanisms, performance optimization techniques. 8. Deployment architecture plan for deploying the system, including environments, tools, and strategies. Key elements. Deployment pipelines, e.g., CI/CD, environment setup, e.g., dev, staging, production, containerization and virtualization. 9. Integration design of how the system integrates with other systems or services. Key elements. Integration patterns, e.g., message queues, service buses, data exchange formats, e.g., JSON, XML, middleware and orchestration. 10. Error handling and logging design of error handling mechanisms and logging strategies. Key elements. Error reporting and notification, logging levels and formats, recovery procedures. 11. Technology stack selection, choosing the appropriate technologies for the project. Key elements. Programming languages, frameworks and libraries, database management systems. 12. Compliance and standards, ensuring the design adheres to relevant standards and regulations. Key elements. Industry standards, e.g., ISO, GDPR, coding standards and best practices, regulatory compliance, e.g., HIPAA, PCI-DSS. 13. Use case diagrams, visual representation of system functionalities and interactions from the user's perspective. Key elements. Actors and their role, system use cases, relationships between use cases. 14. High-level sequence diagrams showing the sequence of interactions between system components or actors. Key elements. Messages exchanged between components, interaction timelines, execution order. 15. Prototyping and proof of concept, POC, creating a preliminary model to test and validate design concepts. Key elements. Prototype development, POC objectives and scope, feedback and iteration. These topics provide a comprehensive understanding of high-level design, covering all the key aspects necessary for creating a robust and scalable system architecture. If you need more details on any specific topic or help in creating content for your videos, let